Hello. Today I am going to deal with instruction set of 8051. So the instruction set of 8051 is classified depending upon the bytes which it is going to take or which it is going to occupy in the memory as 1 byte instructions, 2 byte instructions and 3 byte instructions. You are going to classify the instructions depending upon the function performed by them. That is, it may be the data transfer, it can be the arithmetic, it can be logical, it can be Boolean instructions, or it can be the branching instructions. You can see over here, as the name itself is saying, they are going to say the function performed by those particular instructions. The data transfer instructions, they are going to transfer the data from the source to the destination. It's going to just transfer the data from the source to the destination. It's not going to perform any of the arithmetical or the logical operation. Next one, arithmetic instructions or arithmetic group, wherein it is going to perform the basic arithmetic operations, like it may be the addition, the subtraction, the multiplication, division, incrementing, decrementing. And the logical group, this particular group of instructions, they are going to perform the logical operations, like it may be the AND operation, it may be the OR operation, it may be the NOT operation, it may be the XOR operation, it may be the rotation from the right or rotation from the left through carry or without carry. Such type of functions are going to be performed by the logical group. The Boolean instructions, these are also going to perform the same job as that of the logical instructions. But the difference is, the logical instructions are going to work on the byte. They are going to work on the byte, whereas the Boolean instructions are going to work on the bit. Branching instructions, they are going to help in skipping a set of instructions in a program or repeating a set of instructions for required times. We are going to go for the branching instructions. So these are going to be the classification of the instruction set depending upon the function performed, depending upon the length of the instruction. We are going to classify the instructions as 1 byte instruction, 2 byte instructions and 3 byte instructions. Depending upon the function performed, they are going to be classified as data transfer, arithmetic, logical, Boolean and the branching. And depending upon the type of the addressing mode, we have seen already in the previous class the different types of addressing modes, 5 addressing modes. Depending upon the type of the addressing mode, how the source is being specified, how the source is going to be accessed, that we are going to say the type of the instruction. Okay, so this is going to be the classification of the instruction set. We'll see one by one. While explaining the instructions which belong to the data transfer group, I am going to say about the length of the instruction and the type of the addressing mode which it is using. Okay, so now data transfer group. As the name itself is saying, it is going to transfer the data from the source to the destination. How I can specify the source? The source is a data wherein I can give the data in the instruction only if I follow the immediate addressing mode. I can store the data in the memory location and I can give the address of the memory location in the instruction by using direct addressing mode, or indirectly I can specify the address where the data is residing, that is indirect addressing mode, or I can store the data in a register and I can write the source register in the source place. So if you just recall the instruction format of the instruction in the 8051, you're going to see that you're going to have the opcode field, you're going to have the operand field. In the operand field, you're going to have the destination field, and then you're going to have the source field, the destination field and the source field. Suppose if you want to write any note, any comment on this particular instruction, then the comment should start from a semicolon, and while the assembler assembles our assembly language program, it is going to treat them as a comment and not as an instruction. It should start from a semicolon. And you can have the label, before the opcode, which is separated by a colon, wherein it is optional. This particular label is going to play a very important role when we write the branching instructions in the program. When we write the branching instructions in the program, the label is going to play a very important role. So this is already explained in the previous class. I'm not going to repeat the same, but you just recall that you're going to have the opcode, you're going to have the destination, and then you're going to have the source. Both are going to be separated by a comma. Both are going to be separated by a comma. Always you should know that the opcode is the operation code, which is going to say which operation is going to be performed, and then the source, how I'm going to specify by using different addressing modes, and from the source, the destination, you're going to see the result in the destination. So these are the fields which you have to keep in mind. Whenever we write any instruction, you should be able to separate the opcode field and the operand field. So first instruction which I am going to write over here, say it is move, okay, A comma Rn, move A comma Rn. What is this move? Move is a mnemonic. What do you mean by mnemonic? English like word, you know that one. So it's an opcode. It's an opcode, operation code. Operation code. This particular operation code is saying that we are going to move, we are going to transfer, we are going to copy the data. We are going to copy the data. Where is the data? The data is in the source. The data is in the source. How it is specified? How it is specified? It is specified as Rn. It is specified in the register. See, we have seen the working registers, that is R0 to R7. We are having 8 working registers. Totally, actually in the 8051, we are having 32 working registers in the 4 banks. Each bank consists of 8 working registers. But I can use only one bank at a time. Only one bank at a time. So I say that I am having 8 working registers, R0 to R7. So in the place of the source where I have written n can take up the value 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. That is R0, R1, R2, R3. Yes, ಯಾವ್ದು ರೆಜಿಸ್ಟರ್ ಬೇಕೋ ಆ ವರ್ಕಿಂಗ್ ರೆಜಿಸ್ಟರ್ ನಾ ಇಲ್ಲಿ ಸ್ಪೆಸಿಫೈ ಮಾಡ್ಕೋಬಹುದು. ಅಂದ್ರೆ ಈ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಏನ್ ಹೇಳಿರ್ತದೆ, ಡಾಟಾ ಈಸ್ ದೇರ್ ಇನ್ ದ ವರ್ಕಿಂಗ್ ರೆಜಿಸ್ಟರ್. ದ ಡಾಟಾ ಈಸ್ ದೇರ್ ಇನ್ ದ ವರ್ಕಿಂಗ್ ರೆಜಿಸ್ಟರ್. ಇದ್ರೊಳಗೆ ಡಾಟಾ ಯಾರು ಹಾಕೋರು? ಇದ್ರೊಳಗೆ ಡಾಟಾ ಯೂಸರ್ ಅಂದ್ರೆ ಪ್ರೋಗ್ರಾಮರ್ ಹಾಕೋರು. Right? How you are going to load it? That we are going to discuss it later. So this particular register is having data in it. How much? 8-bit data, 1 byte data is there. That particular byte of data will be copied into the accumulator. It is going to be copied into the accumulator. Andre, whatever the content of Rn is there, that will be copied into the accumulator. That will be copied into the accumulator. So this is going to be the meaning of the instruction. It's going to be the meaning of the instruction. Okay. So now, the length of the instruction, see, we are going to have the fixed format for this one. What is this? Move A comma R0. It's a fixed format. It's a fixed instruction. Move A comma R1. Move A comma R2. You're going to have different codes for these particular instructions. So this particular instruction, it's going to take 1 byte. The code, whatever I am going to get for this particular instruction, it is going to be of 1 byte in length. So we say it's a 1 byte instruction. It's a 1 byte instruction. Right. Now, how the data is being moved, you can see over here, the data is moving from the source register to the destination register. From the source register to the destination register. That is, source operand is the register and the destination operand is also a register. That means I am moving the data from one register to another register. So the type of the addressing mode is register addressing mode. Register addressing mode. So the first one is the meaning. That is, the content of Rn will get copied into the accumulator. This is the meaning of the instruction. Second one, the length of the instruction is 1 byte. The length of the instruction is 1 byte. Third one, we are moving the data from one register to another register. So the type of the addressing mode is register addressing mode. Register addressing mode. Now, the flags which are going to get affected, we have to say about that also. Since I am not performing any of the arithmetical or the logical operation, we are going to say that none of the flags are going to be affected. Actually none of the flags, ಯಾಕಂತಂದ್ರೆ ಡಾಟಾ ಒಂದ್ ಕಡೆಯಿಂದ ಇನ್ನೊಂದ್ ಕಡೆಗೆ ಮೂವ್ ಆಗ್ತೀನಿ. ಆದ್ರೆ ಈ ಕೇಸ್ ದೊಳಗೆ ಏನಾಗ್ತದೆ, you can see over here I am moving the data from the register to the accumulator. Accumulator is a primary register wherein whenever I load any data in the accumulator, the parity flag is going to get affected. The parity flag is going to get affected. ಯಾವಾಗ ನಾ accumulator ದೊಳಗೆ ಡಾಟಾ ಹಾಕ್ತೀನಿ ಅದರೊಳಗೆ ಎಷ್ಟು ಒನ್ಗಳವೆ, ಡಾಟಾದೊಳಗೆ ಎಷ್ಟು ಒನ್ಗಳವ ನೋಡ್ಕೊಂಡು ಅವು ಆಡ್ ನಂಬರ್ ಆಫ್ ಒನ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಪ್ಯಾರಿಟಿ ಫ್ಲಾಗ್ ತಾನೇ ಸೆಟ್ ಆಗ್ತದೆ. ಈವನ್ ನಂಬರ್ ಆಫ್ ಒನ್ಸ್ ಇತ್ತು ಅಂತಂದ್ರೆ ಪ್ಯಾರಿಟಿ ಫ್ಲಾಗ್ ಏನಾಗ್ತದೆ, 0 ಅಂತಂದು ಸೆಟ್ ಆಗ್ತದೆ. ದಿಸ್ ಇಸ್ ದ ಓನ್ಲಿ ಫ್ಲಾಗ್ ವಿಚ್ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಗೆಟ್ ಎಫೆಕ್ಟೆಡ್ if I have loaded the data in the accumulator. Whenever I load the data in the accumulator, the parity flag is going to get affected. It is not going to perform any arithmetical operation. Only by loading the data in the accumulator, the parity flag is going to get affected. So this is going to be the meaning of move a comma rn. Say if I ask you all to write the program that copy the content of the register R1, register R2 into the accumulator. Then what instruction you are going to use? First you have to identify source ಎಲ್ಲದ R1 ಅಥವಾ R2. ಅದರೊಳಗಿನಿಂದ ಎಲ್ಲಿಗೆ ಹಾಕೋರಿ ಅನ್ಲೇತೀನಿ, accumulator ದಾಗ ಹಾಕೋರಿ ಅನ್ಲೇತೀನಿ. ಅಂತಂದ್ರೆ ಸೋರ್ಸ್ ಯಾವ್ದದೆ, R1 ಅದೆ. ಸೊ R1 ಇಂದ accumulator ಗೆ ಕಾಪಿ ಮಾಡ್ರಿ. This is going to be the meaning of that particular thing. Okay, so this is move a comma rn instruction. Okay, then move a comma hash data. Move a comma hash data. You can see over here, just by seeing the hash sign, you should identify the type of the addressing mode. Which type of addressing mode it is? It is immediate addressing mode. In immediate addressing mode, the source operand itself will be the data. ಅಲ್ಲಿ ಇಲ್ಲಿ ಹುಡುಕದ್ ಜರೂರಿ ಇಲ್ಲ, ಆ ರೆಜಿಸ್ಟರ್ ದೊಳಗದ ನೋಡ್ರಿ, ಆ ಮೆಮೊರಿ ದೊಳಗದ ನೋಡ್ರಿ ಅಂತ ಹೇಳೋದಿಲ್ಲ. ಡಾಟಾ ಎಲ್ಲದ ಅಂತಂದ್ರೆ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ದೊಳಗೇನೆ ಅದ. ಆ ಡಾಟಾ ಏನ್ ಮಾಡ್ಬೇಕು, ನಾನು accumulator ದೊಳಗೆ ಕಾಪಿ ಮಾಡ್ರಿ ಅಂತ ಇದ್ರದ್ದು ಮೀನಿಂಗ್. move a comma hash data. The immediate data specified in the instruction will get copied into the accumulator. The immediate data specified in the instruction will get copied into the accumulator. Now, when I have written data, what type of data I can give over here? What type of data? I can give the decimal data, decimal numbers. I can give the hex numbers. I can give the binary numbers. Suppose if I am writing a decimal number, then just write the number. It is going to be understood that it is going to be a decimal number. If you are writing a hex number, it should be given H. After the number, the H letter should be written saying that it belongs to the hexadecimal number system. If it is a binary number, then you are supposed to write a B after the number saying that the number which has been written is binary number, binary data ಅಂತ ಹೇಳಲಿಕ್ಕೆ ಬರೀಬಹುದು. ಸೊ ಯಾವ್ದು ನಿಮಗೆ ಯಾವ್ದು ನಂಬರ್ ಸಿಸ್ಟಮ್ ಬೇಕು ಆ ನಂಬರ್ ಸಿಸ್ಟಮ್ ದೊಳಗೆ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ನೀವು ಇಲ್ಲಿ ಡಾಟಾ ಬರೀಬಹುದು. ಪಾಸಿಟಿವ್ ನಂಬರ್ಸ್ ಬರ್ಕೋಬಹುದು, ನೆಗೆಟಿವ್ ನಂಬರ್ಸ್ ಬರ್ಕೋಬಹುದು. ಯು ಕ್ಯಾನ್ ರೈಟ್ ಎನಿ ಆಫ್ ದ number over there in the immediate data. The thing is, it should be only 8-bit data. It should be a 1-byte data. ಇಲ್ಲಿ ಮೂವ್ a comma ಅಂತಂದು 1 2 3 4 ಹೆಕ್ಸ್ ಅಂತ ನಾ ಬರದೆ ಅಂತಂದ್ರೆ ಇದು ಎಷ್ಟು ಬಿಟ್ ಇಂದ ಆಯ್ತು, 16 ಬಿಟ್ ಇಂದ ಆಯ್ತು. ಬಟ್ ನಮ್ಮ ಅಕ್ಯುಮುಲೇಟರ್ ಎಷ್ಟು ಬಿಟ್ ಇಂದ ಅದ, ಬರೀ 8 ಬಿಟ್ ಇಂದ. 16 ಬಿಟ್ ಡಾಟಾನ ನಾ 8 ಬಿಟ್ ರೆಜಿಸ್ಟರ್ ದೊಳಗೆ ಹಾಕ್ಲಿಕ್ಕೆ ಆಗಂಗಿಲ್ಲ. So this is going to be the wrong instruction. It's going to be an illegal instruction because 16-bit cannot be made to stored in the 8-bit register. For that reason, you have to take care that when this is a 8-bit register, when the destination is a 8-bit register, take care that the immediate data whatever is being written, it is going to be 8-bit only. 8-bit ಇಂದೇ ಜಾಸ್ತಿ ನಮ್ಮ ಮೈಕ್ರೋಕಂಟ್ರೋಲರ್ ಇರೋದೇ 8-bit ಮೈಕ್ರೋಕಂಟ್ರೋಲರ್ ಅದ. ಹೌದು, ಅಂದ್ರೆ 8-bit ಗಿಂತ ದೊಡ್ಡದು ನಮ್ದು ಡಾಟಾ ಇತ್ತು ಅಂದ್ರೆ ಏನ್ ಮಾಡ್ಬೇಕು, ಅದನ್ನ ನಾನು ಡಿವೈಡ್ ಮಾಡಿ ಕೊಡ್ಬೇಕು. 8-bit ಡಿವೈಡ್ ಮಾಡ್ಕೊಂಡು ಕೊಡ್ಬೇಕು. So that is going to be the thing. So move a comma hash data. Now, just by seeing the hash sign, you're going to say that it is immediate addressing mode. And since I am loading the data in the accumulator, the parity flag is going to get affected. And the length of the instruction. Coming to the length of the instruction. See, for this particular format, which is the format move a comma hash. ಇಲ್ಲಿ ಡಾಟಾನ ಯೂಸರ್ ಡಿಫೈನ್ಡ್, ಒಬ್ಬೊಬ್ರು ಒಂದೊಂದು ನಂಬರ್ ಬರ್ಕೋಬಹುದು, ಹೌದಾ? ಸೊ ದಿಸ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಡಾಟಾ ಇಸ್ ಗೋಯಿಂಗ್ ಟು ಟೇಕ್ 1 byte. ಯಾಕಂತಂದ್ರೆ 8 bit ಡಾಟಾ ಬರೀತೀನಿ, ಅದು 1 byte. ಈ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಫಾರ್ಮ್ಯಾಟ್, ದ ಆಪ್ಕೋಡ್ ಈಸ್ ಗೋಯಿಂಗ್ ಟು ಬಿ ಆಫ್ 1 byte. So the total length of the instruction will be 2 bytes. It is going to be 2 bytes. Which flag will be affected? The parity flag. Which is the addressing mode? Immediate addressing mode. What's the length of the instruction? It is going to be 2 byte. Have in mind, immediate data 1 byte in ittu andre length of the instruction 2 byte irtadri. Immediate data 16 bit in andre 2 byte ittu antandre length of the instruction will be 3 byte. We are going to see that instruction also. So this is going to be the second instruction, move a comma hash data. Next one. Move a comma direct. Move a comma direct. What does it mean? Here direct means I am going to give the address. I am going to give the address of the memory location where I have stored the data. Say for example, so this is going to be the memory, and let me take the address 20 hex. This is the address of this particular line 20 hex, and I am going to load certain data, say 11 hex. I want to copy this particular 11 hex in the accumulator. I want to copy 11 hex in the accumulator by using this instruction. Then what I am going to do is I am going to write move a comma 11 hex ಎಲ್ಲಿ stored ಇದೆ 20 hex ಅನ್ನೋ memory location ದೊಳಗೆ. So directly I am going to write the address, that is 20 hex. So if there is no hash sign, then the number will be treated as address. ಇದನ್ನ ತಲೆಗೆ ಇಟ್ಕೋಬೇಕು. ಪ್ರೋಗ್ರಾಮ್ ಬರೆಯೋ ಇದ್ರೊಳಗೆ ಹ್ಯಾಶ್ ಸೈನ್ ಬಿಟ್ಟೋಗ್ಬಿಡ್ತು ಅಂತಂತಂದ್ರೆ ಆ ನಂಬರ್ ಹೋಗಂಗಿಲ್ಲ. ಏನ್ ಹೋಗ್ತದೆ, ಆ ನಂಬರ್ ಏನಂತ ಕನ್ವರ್ಟ್ ಆಗ್ಬಿಡ್ತದೆ, ಅಡ್ರೆಸ್ ಅಂತ ಕನ್ವರ್ಟ್ ಆಗ್ತದೆ. ಆ ಅಡ್ರೆಸ್ಸಿಗೆ ಹೋಗ್ತದೆ, ಅದ್ರೊಳಗೆ ಏನ್ ಡಾಟಾ ಇರ್ತದೆ ಅದನ್ನ ತಗೊಂಡ್ ಬಂದು ಡೆಸ್ಟಿನೇಷನ್ ಆಗ್ತದೆ. ಸೊ ಹ್ಯಾವ್ ಇನ್ ಮೈಂಡ್, ಇಫ್ ಐ ಹ್ಯಾವ್ ರಿಟರ್ನ್ ಅ ನಂಬರ್ without the hash sign, it means that it is the address of the memory location. ಆ memory location the content ಏನಿರ್ತದೆ, that will be copied into the accumulator. Here in this case 20 hex ದೊಳಗೆ 11 hex ಹಾಕಿನಿ, ಹೌದು. 20 hex ದಾಗ ನಾ ಏನ್ ಬರ್ಕೊಂಡಿನಿ, 11 hex ಅನ್ನೋ ಡಾಟಾ ಬರ್ದೀನಿ. So if I write the instruction like this, move a comma 20 hex, then what's going to happen, the content of 20 hex ಅನ್ನೋದು ಅಡ್ರೆಸ್, ಅದರದ್ದು ಕಂಟೆಂಟ್ ಏನದ 11 hex. That particular 11 hex will become the content of the accumulator. So here the addressing mode which is used is direct addressing mode. What is the length of the instruction? ಇಲ್ಲಿ ಅಡ್ರೆಸ್ ಯಾವಾಗ್ಲೂ 8 bit ಅಡ್ರೆಸ್ ಇರ್ತದೆ, 1 byte. It is going to take 1 byte. ಸೊ ಇದು ಯೂಸರ್ ಡಿಫೈನ್ಡ್, ಒಬ್ಬೊಬ್ರು ಒಂದೊಂದು ಅಡ್ರೆಸ್ ಕೊಡ್ಬೋದು, ಹೌದು. ಸೊ ಇದಕ್ಕೆ 1 byte ರಿಸರ್ವ್ ಇರ್ತದೆ, 1 byte. ಈ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಂದ್ರೆ ಆಪ್ಕೋಡ್ಗೆ ಎಷ್ಟು ತಗೋತದ, 1 byte. ಆಲ್ವೇಸ್ ಆಪ್ಕೋಡ್ ವಿಲ್ ಬಿ 1 byte. ಸೊ ಇದು 1 byte, ಇದು 1 byte. ಟೋಟಲ್ ಲೆಂತ್ ಆಫ್ ದ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ವಿಲ್ ಬಿ 2 bytes. It's going to be 2 bytes. Again, which flag will be affected? Since I am loading the data in the accumulator without performing any of the operation, just by copying the data in the accumulator, the parity flag is going to get affected. Okay, next. Move a comma at ri. Move a comma at ri. ಇಂಡೈರೆಕ್ಟ್ ಅಡ್ರೆಸ್ಸಿಂಗ್ ಮೋಡ್ ಅದ. ಅಟ್ ಸೈನ್ ನೋಡಿದ ತಕ್ಷಣನೇ ನಿಮಗೆ ಗೊತ್ತಾಗಬೇಕು ಏನದಿದು ಇಂಡೈರೆಕ್ಟ್ ಅಡ್ರೆಸ್ಸಿಂಗ್ ಮೋಡ್. ಯಾಕಂದ್ರೆ ಅಡ್ರೆಸ್ಸಿಂಗ್ ಮೋಡ್ ಆಗಲೇ ಓದಿವಿ ನಾವು. ಸೊ ಇಂಡೈರೆಕ್ಟ್ ಅಡ್ರೆಸ್ಸಿಂಗ್ ಮೋಡ್ ಅದು. ಇಂಡೈರೆಕ್ಟ್ ಅಡ್ರೆಸ್ಸಿಂಗ್ ಮೋಡ್ ದೊಳಗೆ ನಾವೇನ್ ಮಾಡ್ತೀವಿ, ಮೆಮೊರಿ ಪಾಯಿಂಟರ್ಸ್ ನ ಯೂಸ್ ಮಾಡ್ಕೋತೀವಿ. ವಿ ಆರ್ ಗೋಯಿಂಗ್ ಟು ಯೂಸ್ ದ ಮೆಮೊರಿ ಪಾಯಿಂಟರ್ಸ್. ಯಾವ್ದಾವ್ದು ಮೆಮೊರಿ ಪಾಯಿಂಟರ್ ಅದೇ, R0 ಮತ್ತೆ R1 ಅನ್ನೋ ವರ್ಕಿಂಗ್ ರೆಜಿಸ್ಟರ್ ನ ನಾವು ಮೆಮೊರಿ ಪಾಯಿಂಟರ್ ಅಂತಂದು ಯೂಸ್ ಮಾಡ್ಕೋಬಹುದು. ಅಂದ್ರೆ ಇಲ್ಲೇನ್ ನಾ ಐ ಬರ್ದೀನಿ, ಐ ಕ್ಯಾನ್ ಟೇಕ್ ಅಪ್ ದ ವ್ಯಾಲ್ಯೂ 0 or 1. It can take up the value 0 or 1. So R0 ಅರ ತಗೋಬಹುದು, R1 ಅರ ತಗೋಬಹುದು. ಸೊ ಏನ್ ಮಾಡ್ತದೆ ಇದು, ಇಂಡೈರೆಕ್ಟ್ಲಿ ಡಾಟಾನ ಪಾಯಿಂಟ್ ಮಾಡ್ಲಿಕ್ಕೆ, ಅಂದ್ರೆ ಎಕ್ಸಾಂಪಲ್ ಹೇಳ್ತೀನಿ. ಸೇ ಮೂವ್ a comma at R0. The meaning of this particular instruction is copy the content of the memory location. Copy the content of the memory location whose address is specified in the memory pointer R0 into the accumulator. ಅಂದ್ರೆ ಏನು, R0 ಒಳಗೆ ಒಂದೇನು ನಂಬರ್ ಅದೇ, ಆ ನಂಬರ್ ಅಲ್ಲ, ಏನದದು, ಅದು ಅಡ್ರೆಸ್. ಯಾವಾಗ ಅಡ್ರೆಸ್ ಅಂತ ಟ್ರೀಟ್ ಆಗ್ತದೆ, ನಾ ಇಲ್ಲಿ ಎಟ್ ಅಂತ ಬರಿತೀನಲ್ಲ, ಅವಾಗ ನಂಬರ್ ಏನಾಗ್ತದೆ, ಅಡ್ರೆಸ್ ಅಂತಂದು ಟ್ರೀಟ್ ಆಗ್ತದೆ. ಆ ಅಡ್ರೆಸ್ ಒಳಗೆ ಏನ್ ಡಾಟಾ ಇರ್ತದೆ, that will be copied into the accumulator. That will be copied into the accumulator. When this instruction gets executed, the content of the memory location, whose address is specified in R0 or R1 will get copied into the accumulator. ಇನ್ನ ಸಿಂಪಲ್ ಹೇಳಬೇಕು ಅಂತಂದ್ರೆ, the content of Ri. Content of Ri ಏನಿರ್ತದ, ಅಡ್ರೆಸ್. ಆ ಅಡ್ರೆಸ್ ಕಂಟೆಂಟ್ ಏನಿರ್ತದ, ಡಾಟಾ. That data will be copied into the accumulator. So this is going to be the indirect addressing mode instruction. ಯಾಕೆ ಸೋರ್ಸ್ ಹೆಂಗ್ ಹೇಳಿರತ್ತೀನಿ, ಸೋರ್ಸ್ ನ ಇಂಡೈರೆಕ್ಟ್ಲಿ ಪಾಯಿಂಟ್ ಮಾಡ್ಲತ್ತೀನಿ. ಸೊ ಇದು ಇಂಡೈರೆಕ್ಟ್ ಅಡ್ರೆಸಿಂಗ್ ಮೋಡ್. What is the length of the instruction? ನೋಡ್ರಿ, move a comma at R0. ಇದು ಫಿಕ್ಸ್ಡ್ ಫಾರ್ಮ್ಯಾಟ್. ಇದ್ರೊಳಗೆ ಎಲ್ಲಿನೂ ಯೂಸರ್ ಡಿಫೈನ್ಡ್ ನಂಬರ್ಸೇ ಬರಂಗಿಲ್ಲ. So the length of the instruction is going to be 1 byte. And the type of the addressing mode is indirect addressing mode, and again the parity flag is going to get affected. Over here. So this is going to be move a comma at Ri. ಅಂದ್ರೆ ಇದು ಒಂದೊಂದು ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಮೊದಲು ನೋಡ್ರಿ, move a comma Rn ಅಂದ್ರೆ 8 ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಮುಗ್ದಂಗ. Like that you are going to see move a comma at Ri ಓದಿದ್ವಿ ಅಂತಂದ್ರೆ 2 ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಮುಗ್ದ. So you are going to have the next instruction. We'll move on to the next instruction. Move Rn, A. So you can see over here. Now the source is the accumulator and the destination is the working register. Any working register right from R0 to R7. What happens when this instruction gets executed? Accumulator dolaga ಏನು ಡಾಟಾ ಅದೇ, that will be copied into the register Rn. It is going to be copied into the register Rn. Now if you just look into, we are moving the data from one register to another register. So the type of the addressing mode is register addressing mode. The length of the instruction is going to be 1 byte. ಯಾಕಂತಂದ್ರೆ ಇಲ್ಲಿ ಫಿಕ್ಸ್ಡ್ ಫಾರ್ಮ್ಯಾಟ್ ರೀ. ಏನ್ ಫಿಕ್ಸ್ಡ್ ಫಾರ್ಮ್ಯಾಟ್ ಅಂದ್ರೆ, move R1, A, move R2, A, R3, A. ಇವಕ್ಕೆ ಒಂದೊಂದು ಕೋಡ್ ಫಿಕ್ಸ್ಡ್ ಇರ್ತವೆ. ಇದರೊಳಗೆ ಎಲ್ಲಿನೂ ಯೂಸರ್ ಡಿಫೈನ್ಡ್ ಇಮಿಡಿಯೇಟ್ ಡಾಟಾನೂ ಇಲ್ಲ, ಯೂಸರ್ ಡಿಫೈನ್ಡ್ ಅಡ್ರೆಸಸ್ನೂ ಇಲ್ಲ. ಸೊ ಫಿಕ್ಸ್ಡ್ ಫಾರ್ಮ್ಯಾಟ್ ಇದಕ್ಕೆ. ಲೆಂತ್ ಆಫ್ ದ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಏನದ, ಇದು 1 byte ಅದ. ಲೆಂತ್ ಆಫ್ ದ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ is 1 byte. And since we are loading the data in the working register, none of the flags are going to get affected. See, whenever you explain any instruction, you have to say about all these things. What's the function performed, what type of addressing mode it is using, what's the length of the instruction, and which flags are going to get affected. Ishtu helidre matra idu complete answer agtade. So this is going to be move Rn, A. Okay, now let me give an example for this one. Move a comma hash 11x. Move a comma hash 11x. What's going to happen when this instruction gets executed? ಇದನ್ನು ನೋಡಿ ಹೀಗೆ ಮೊದಲೇ move a comma hash 11x ಅಂತಂದ್ರೆ accumulator ದೊಳಗೆ 11x ಲೋಡ್ ಆಗ್ತದೆ. Immediate data will get loaded in the accumulator. Now if I write move a comma R3, ಈ ರೀತಿ ಬರದೆ ಅಂತಂದ್ರೆ accumulator is a source, R3 is the destination. ಅಕ್ಯುಮುಲೇಟರ್ ದೊಳಗೆ ಏನ್ ಡಾಟಾ ಅದ, ಅದು ಎಲ್ಲಿಗೆ ಬರ್ಬೇಕ್ರಿ, R3 ಗೆ ಬರ್ಬೇಕು. ಅಕ್ಯುಮುಲೇಟರ್ ದೊಳಗೆ ಏನ್ ಡಾಟಾ ಅದ, 11x. That will be copied into the R3 register. So you should have in mind that the source register and the destination register should get matched in size. It should get matched in size. ಇದು 8 bit ಇತ್ತು ಅಂತಂದ್ರೆ ಇದನ್ನು 8 bit ಇರಬೇಕು. Okay, one 16 bit ಒಂದು 8 bit ಇತ್ತು ಅಂತಂದ್ರೆ you are not going to have the matching between the source and the destination, and that's going to be an illegal instruction. Okay, next move Rn, direct address. Move Rn, direct. So what is this? This is the internal RAM address. So it's going to be an 8-bit address. 8-bit address. ಯಾಕೆ internal RAM user ಗೆ available ಇರೋದೇ 128 bytes. So 8 bit address ಇಲ್ಲಿ. So what is going to happen when this instruction gets executed? The content of the memory location, the content of the direct address, the content of the direct address will become the content of the specified register, will become the content of the specified register. What does it mean? Say I am having 20 hex memory location. ಅದರೊಳಗೆ ಎಂತದೋ ಒಂದು ಡಾಟಾ ಬರ್ದೀನಿ, say A B hex, right? It's a usual practice. If the number is starting from an alphabet, then precede it with a 0. So ಇಲ್ಲಿ 0 ಬರೀಲಿಲ್ಲ ಅಂದ್ರೂ ನಡೀತದೆ. ಆದ್ರೆ ನಮಗೆ ಗೊತ್ತಾಗಬೇಕು, ನಮಗೆ ಪ್ರಾಕ್ಟೀಸ್ ಆಗಬೇಕು ಅಂತಂದ್ರೆ ಇಲ್ಲಿ 0 ಬರ್ಕೋತೀನಿ. Now if I write move R4, 20 hex ಅಂತ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಬರದೆ ಅಂದ್ರೆ ಏನರ್ಥ? 20 hex ಅನ್ನೋ ಮೆಮೊರಿ ಲೊಕೇಶನ್. ಇಲ್ಲಿ ಹ್ಯಾಶ್ ಸೈನ್ ಇಲ್ಲ. ಹ್ಯಾಶ್ ಸೈನ್ ಇದ್ರೆ 20ನೇ ಕಾಪಿ ಆಗ್ತದೆ. ಹ್ಯಾಶ್ ಇದ್ದಿದ್ದಿಲ್ಲ ಅಂದ್ರೆ ಆ ನಂಬರ್ ಏನ್ ಬರ್ದಿರ್ತದೆ ಅದು ಏನಿರ್ತದೆ? ರ್ಯಾಮ್ ಅಡ್ರೆಸ್ ಇರ್ತದೆ. ಸೊ ಅಡ್ರೆಸ್ ಒಳಗೆ ಏನ್ ಡಾಟಾ ಅದೇ, ವಾಟ್ ಎವರ್ ದ ಕಂಟೆಂಟ್ ಆಫ್ ದ memory location is there, that will get copied into the destination register, that is R4. That is the content of 20 hex will become the content of R4, will get copied into R4. Andre R4 dolage ಏನು ಬರ್ತದೆ? AB hex ಅಂತ ಬರ್ತದೆ. So this is going to be the meaning of this instruction. Okay, now what is the type of the addressing mode? It is direct addressing mode. It is direct addressing mode. And the length of the instruction, ಯಾವಾಗಲೂ 8 bit address 1 byte. ಆಮೇಲೆ ಇದು opcode ಎಷ್ಟು ತಗೋತದೆ? 1 byte. So the total length of the instruction will be 2 bytes. And which flag is going to get affected? None of the flags. ಯಾಕೆ destination ಏನದೆ? ಒಂದು register ಅದು. ನಾನು accumulator ತಂಟಿಗೆ ಹೋಗ್ಲಿರ್ತಿಲ್ಲ. So none of the flags are going to get affected over here. So this is going to be the mean. Next, move rn, hash data. Rn, hash data. It's an immediate data, and it is going to be the 8-bit data. So what happens when this instruction gets executed? The immediate data specified in the instruction, will become the content of Rn, will get copied into the Rn. So here ಬರಿಬೇಕಿದನ್ನ ಏನು? Immediate data will become the content of the register Rn. What is the length of the instruction? Idu 1 byte, opcode 1 byte. So the length of the instruction is going to be 2 bytes. Type of the addressing mode is immediate addressing mode. And which flags are going to get affected? None of the flags are going to get affected. So this is going to be the meaning of the instruction move Rn, wherein we have discussed 4 instructions which are having the destination as Rn. Previous dolage destination ittu, accumulator ittu. So this is going to be the meaning of these particular instructions. We'll move on to the next instructions in the data transfer group, wherein you're going to see that the destination will be the internal RAM address. It's going to be the address, and here you are going to have the different types of the addressing mode. What is it? Say you can have the immediate data. So what's going to happen when this instruction gets executed? When this instruction gets executed, the immediate data specified in the instruction, will become the content of the memory location, whose address is specified in the instruction only, right? So if I want to give the example, move 20 hex, hash 7 hex ಅಂತ ಬರದೆ ಅಂತ ತಿಳ್ಕೊರಿ. So you just see here, this is the immediate data. So this is going to be copied ಎಲ್ಲಿ? destination ದೊಳಗೆ ಏನದೆ? ಒಂದು ನಂಬರ್ ಅದ. ಆ ನಂಬರ್ ಏನು? It is address of the memory location. So 20 hex ದೊಳಗೆ ಏನು ಕಾಪಿ ಆಗ್ಬಿಡ್ತದ್ರಿ? 11 hex ಕಾಪಿ ಆಗ್ತದೆ. So this is going to be the meaning of the instruction. ಏನರ್ಥ? The immediate data specified in the instruction will become the content of the memory location. ಎಲ್ಲಿ ಕಾಪಿ ಆಗ್ತದ? ಮೆಮೊರಿ ಲೊಕೇಶನ್ ಕಾಪಿ ಆಗ್ತದೆ. ಅದರ ಅಡ್ರೆಸ್ ಎಲ್ಲದೆ? ಅದರ ಅಡ್ರೆಸ್ ಇಲ್ಲೇ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ದೊಳಗೇನೆ ಅದ. So the immediate data specified in the instruction will become the content of the memory location whose address is specified in the instruction only. Whose address is specified in the instruction only. So here the type of the addressing mode, ಏನದೆ source ನ ನೋಡಬೇಕು, immediate addressing mode ಅದು. source ನ ನೋಡಬೇಕು, immediate addressing mode ಅದು. destination ಹೆಂಗೆ ಹೇಳಿರೋದೇ direct addressing mode. ಮೊದಲು ಯಾವಾಗಲೂ source ಇಂದ ಹೇಳಬೇಕ್ರಿ. ಮೊದಲು ಯಾವಾಗಲೂ source ನಿಂದ. Second one. So what's going to happen? The immediate data will become the content of the address. It's going to become the content of the address. This is the meaning of the instruction. Third one. Which flags are going to get affected? Which flags? None of the flags. ಯಾಕಂತಂದ್ರೆ immediate data ನ ಎಲ್ಲಿ ಲೋಡ್ ಮಾಡ್ಲಿತೀನಿ ಯಾವುದೋ memory location ಒಳಗೆ. And I am not going to perform any of the operation, maybe arithmetical or the logical. So none of the flags are going to get affected. Now the most important one is the length of the instruction. See, length of the instruction ನಮಗೆ ಯಾವಾಗಲೂ ಗೊತ್ತಿತ್ತು ಅಂತಂತಂದ್ರೆ ಪ್ರೋಗ್ರಾಮ್ ಸೈಜ್ ನ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬಹುದು. ಹೆಂಗೆ ಪ್ರೋಗ್ರಾಮ್ ಸೈಜ್ ಸಣ್ಣದಾಕೋತ ಹೋಗ್ತದೆ, ಎಕ್ಸಿಕ್ಯೂಷನ್ ಟೈಮ್ ಅಷ್ಟೇ ಸಣ್ಣದಾಗ್ತದೆ ಅಂದ್ರೆ ನಂಗೆ ರಿಸಲ್ಟ್ ಜಲ್ದಿ ಬರ್ತದೆ. Okay, so the time taken to execute a program will become very lesser, the time. Okay, now the length of the instruction you can see over here. ಇದು ಇಂಟರ್ ಇನ್ಸ್ಟ್ರಕ್ಷನ್ ಆಪ್ಕೋಡ್ ಯಾವಾಗ್ಲೂ 1 byte ರೀ. ಆಪ್ಕೋಡ್ ಯಾವಾಗ್ಲೂ 1 byte. ಈಗ ಇಲ್ಲಿ ಇಮಿಡಿಯೇಟ್ ಡಾಟಾ ಇದೆಷ್ಟದ 1 byte ಅದ. ಇದು ಅಡ್ರೆಸ್ ಎಷ್ಟದ 1 byte ಅದ. ಇದನ್ನು ಯೂಸರ್ ಡಿಫೈನ್ಡ್, ಸೊ ಇದಕ್ಕೆ 1 byte, ಇದಕ್ಕೆ 1 byte. ಆಪ್ಕೋಡ್ಗೆ 1 byte. So the total length of the instruction is 3 bytes. The total length of the instruction is 3 byte. Okay, so this is going to be the information about move address comma hash data. You can see over here move one example program ಬರಲಿರ್ತೀನಿ 20 hex comma hash 0 AA hex. Move 30 hex comma hash 55 hex. So what is this? What's the meaning? The meaning is the first instruction AA hex is a immediate data. That data will become the content of 20 hex memory location. Second one again another 55 hex is a immediate data. It will become the content of the destination address, that is 30 hex. This is going to be the meaning. So idu 1 byte tagotuda, idu 1 byte tagotuda, opcode 1 byte. So total length is going to be 3 byte. Okay, now you can have move address comma address. You can see over here in the place of the source also I am having the direct address, and in the place of the destination also I am having the address. That means I am moving from one memory location to another memory location. This particular instruction format is available only in the microcontroller 8051, and you are not going to have it in the microprocessor. You cannot copy directly the data from one memory location to another memory location. So what is the meaning over here? The content of the address 2, source address will become the content of the address 1. It is going to get copied into the address 1. Example kodbekantandre, say I'll write like this: move 20 hex comma 30 hex. In artha idrolaga source idu, idenadru destination adu. So number without a hash sign andre idenadru one address adu. So 30 hex dolaga enu content ade, that will become the content of the memory location 20 hex. So what is the length of the instruction? Idu 1 byte. Opcode 1 byte. So the total length of the instruction is going to be 3 bytes. Type of the addressing mode, direct addressing mode. And none of the flags are going to get affected. Yake? We are not loading we are not loading it in the accumulator, or we are not performing any arithmetical or the logical operation. So this is going to be move address 1 comma address 2. Next instruction, move address comma at RI. Indirect addressing mode instruction ade. ಏನಂತಾರೆ, I can take up the value 0 or 1. What is going to happen when this instruction gets executed? the content of the memory location. ಯಾಕಂತಂದ್ರೆ at ಮತ್ತೆ r out ಅಥವಾ r1 ಅಂತ ಬರ್ದ್ವಿ ಅಂತಂದ್ರೆ it is the memory pointer which is pointing certain address of the memory location. So the content of the memory location whose address is held by r0 or r1 will become the content of the address, specified address. Let me take an example. Say move r0 comma hash 20 hex. ಅಂದ್ರೆ r0 ಒಳಗೆ ಏನು ಲೋಡ್ ಆಯ್ತು, r0 ಒಳಗೆ 20 hex ಲೋಡ್ ಆಯ್ತು. Okay, now and write move 40 hex comma at r0. Move 40 hex comma at r0. What's going to happen when this instruction gets executed at r0? ಅಂದ್ರೆ r0 ಒಳಗೆ ಒಂದೇನೋ ನಂಬರ್ ಅದು, ಏನದ 20 hex ಅದು. ಅದು ನಂಬರ್ ಏನದು, ಅದು ಇಂಟರ್ನಲ್ ರ್ಯಾಮ್ ದ ಅಡ್ರೆಸ್ ಅದು. ಯಾಕೆ ಅಟ್ ಸೈನ್ ಅದು ಮೆಮೊರಿ ಪಾಯಿಂಟರ್ ಅಂತ ಯೂಸ್ ಮಾಡ್ಲಿರ್ತೀನಿ. ಸೊ 20 hex ಅನ್ನೋ ಮೆಮೊರಿ ಲೊಕೇಶನ್ಗೆ ಹೋಗ್ತದೆ. ಆ 20 hex ಅನ್ನೋ ಮೆಮೊರಿ ಲೊಕೇಶನ್ ಒಳಗೆ ಏನು ಡಾಟಾ ಸೇವ್ ಆಗಿರ್ತದೆ, that will become the content of 40 hex. That will become the content of the 40 hex. So what is the meaning, what is the length of the instruction? See, the opcode is going to take 1 byte. The opcode is going to take 1 byte and the destination address is going to take 1 byte. So the length of the instruction is going to be 2 bytes. None of the flags are going to get affected. None of the flags are going to get affected. So this is going to be the meaning of move address comma at ri.